All right, so let's take a look at queues. Like I said in the intro, queues are an abstract data type. Just like stacks, they dictate how we can access the data. And just like stacks, we use other data structures to implement them. Now, unlike stacks, queues enforce a FIFO behavior. FIFO is first in, first out. Remember that stacks were LIFO, last in, first out. So queues are called queues because they're like lineups. And lineups are called queues in some parts of the world. So, if you're at a store and you get in a line, the people in front of you will be served before you are. So you'll join the queue at the end, and then the people in line are going to be serviced in the order that they join the queue. So the first person in line is going to be served, and then the second person in line, and then the third person in line, etc. That's the theory anyway. In real life, people can butt in, but when we're dealing with the data structure queues, nobody gets to butt in. So items are removed from the queue in the same order that they're added to the queue. So if we add item 1, item 2, and item 3, then we have to remove item 1 first, and then item 2, and then item 3. So it's first in, first out. With stacks, it was the last item that was removed first. So if we added item 1, item 2, item 3, it would be item 3 that was removed first. But with queues, you're removed in the order you were added. Now, just like with stacks, there are 3 main operations that we can perform on queues. We can add an item to the end of the queue, and that's also called onQueue or enqueue. We can remove the first item in the queue, and that's also called dequeue. And just like with stacks, we can peek at the queue, and that gets the item at the front of the queue without removing it from the queue. Now, just like with stacks, there are 2 popular ways of implementing queues: arrays and linked lists. All right, so here's a queue, and 10 is at the front and 22 is at the back. So these items were added to the queue in the order 10, 15, 4, and 22. And then if we add 20, we're going to add 20 to the back of the queue. So here's our queue before we add 20, and when we add an item, the front of the queue doesn't change, but the back will be now pointing to the new item. If we remove an item, we're going to remove the item from the front. So we're going to remove 10, and the front now points to 15. Now, depending on the implementation, you might clean up the 10, but this is essentially how it works. So if you add an item, the back pointer will change, and if you remove an item, the front pointer will change. And of course, if we were now to peek, the peek value would be 15, but nothing in the queue changes. So when we peek, we get the item at the front of the queue, but we don't remove it from the queue. So nothing changes, the front pointer will not change. Now, I didn't add a slide for time complexity, but if you're wondering about that, it will be a similar situation we had with stacks. It's going to depend on what you're backing the queue with. If you're backing a queue with an array, then whether an operation is going to be constant time or linear time is going to depend on whether you have to resize the array. If you're backing it with a linked list, these 3 queue operations will always be constant time. Okay, so now that we know what a queue is and what operations we can do on it, let's go ahead and implement a simple queue. I'll see you in the next video.